probability. And so a few important things that you should know. Number one, probability is the proportion of times the outcome occurs in a very long sequence of repetitions. And so probability oftentimes is talked about as a fraction, like 6 out of 7 times this is going to happen. You can use a decimal to represent probability, like 0.35. You can also talk about it as a percentage. 73.4% of the time this occurs. And all of our probabilities are numbers that will be between 0 and 1. And oftentimes they will talk about these things when you see the probability as the probability of x occurring equals 0.68 or something like that, as an example. So the x is the event that's occurring. So you might say something like if you're flipping a coin, the probability of getting a tails, and then you'd have equals 0.5. And we have two different kinds of probabilities, really. We have something we call experimental probability, like you do an experiment, do a bunch of trials, and you find that probability. And then we also have something called theoretical probability, like over an infinite amount of trials, you would expect to see this. Okay, and so there's two different kinds of probability. They really are representing the same thing. One is about a sample, that's what our experiments are all about and what statistics is generally about. And then one is about the population, if you can do something forever. Down below here, you see an example of flipping a fair coin, meaning it has heads and tails, and you expect to see heads half the time because there's two sides. And you watch the graph, and in the first 20 tosses, you see what happens with the number of tosses that you have. So you see, oh, I have this happening, this happening, this happening, this happening, and over time, with the number of tosses, you see that you start to get closer and closer to what you would expect to see. Half of the tosses are going to be heads. And then on the right-hand side, you see a diagram of what happens after 500 tosses. And for those of you who have taken AP Calc, and probably if you remember in pre-calc, we had something called logistic growth, where over time you see something that looks like this, where there's a graph and then it levels off after a while. And sometimes they call that the carrying capacity or whatever. Probability is kind of like that over an infinite number of trials. Over a certain amount of time, the theoretical probability approaches something. And in the second graph, you can see how it's approaching 50%. According to the Book of Odds, the probability that a randomly selected U.S. adult usually eats breakfast is 0.61. So what does this 0.61 mean? And for us, when we talk about probability, usually we're trying to talk about, as much as we can, large samples. So this means with a large, which is very important, sample, we would expect 61% of interviewed adults to eat breakfast. Why doesn't it mean that exactly 61 of 100 eat breakfast? And this is because every sample could have a different outcome, even if it is likely that 0.61 of them eat breakfast. Down below here we have some examples of probabilities, and we're going to try and match these up with what we would think that they would be. So in the first one, an outcome that is impossible, it can never occur, that would be a 0 probability. The probability is 0 because the event is impossible. So something that's impossible would have a probability of 0. In the second one, the outcome is certain. So the answer there would be a 1. And the reason is the likelihood is a guaranteed outcome. Like death, for example, everybody dies. This outcome is very unlikely, so I'll highlight that word. That means it must have a very small probability. So I would say 0.01. This event has a small chance of occurring. And the outcome will happen more often than not. I would say that looks like it would be the 0.61. That's because the probability has to be more than 0.5. Okay, so short run regularity is one of the myths that we have in probability. The idea that probability, that its randomness is not only predictable in the long run, but also in the short run too. So this is what we were talking about a little bit earlier with that there's really two kinds of probability we talk about, the experimental kind and the theoretical. Over time, we saw in the coin flipping that something approached 0.5, but the truth is it is possible that if all of us flipped a coin 10 times, one of us might get heads 10 times in a row. It could happen. And then you might think, oh, it's 100% certainty I'm going to get heads. So, a myth. Some example activities that we could do to figure this out. Pretend that you're flipping a coin. And without flipping it, imagine the first toss. Write down the result in your mind. And then write down the toss. Okay, so go ahead, write down the toss. Number 1. Being the kind of boring person that I am, I'm just going to go with my first toss was a heads. And then my second toss was a tails. And you keep doing this until you record the results of 50 imaginary flips. Write your results down below in groups of 5 to make them easier to read. All right, so let's see. I don't really want to do that, so let's just start writing some stuff down. Do you want me to use parts of the results, or do you want to just make up our own? Oh, God, okay, fine. Whatever. All right, so let's go with H, T, T, H, T. It's in groups of 5, so I'm going to skip a space. T, T, H, H, T, that boy. H, T, T, H, H. I'll keep continuing over here. T, H, T, H, 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 T, T, H, T. What did I have so far? 1, 2, 3, 4, 5. How about T, H, T, T, H, H, T, T, H, T, H, H, T, H, T. Running out of room. Triple T, H, H, and H, H, T, H, T. I'll pause there. Okay, so in probability, sometimes they talk about runs. And so what we're going to look for is we're going to look for runs. I'm going to work from the 8 down back the other way. Do we see a run like 8 H's in a row or 8 T's in a row anywhere? No. So I'm going to write down that there are 0 runs of 8. How about any runs of 7?
No.
Okay. 6s.
No.
A 5?
No.
So there's no 5s. I just want to make sure. How about, you said I know there's at least one 4.
4.
So here's a 4.
I see.
Where's the second?
Is there another 4?
There's 4
Yeah.
H's in the last 2.
Yeah.
3 there.
Oh, that's
And then
what
there's
you
4
got.
T's right before.
Right here is 4 T's.
Oh,
Yeah.
yeah.
Okay, so there's 4 T's. Here's one over here. And then that's 4. Any other ones? Okay, so there are 2 runs of 4. Let's look for runs of 3 now. Runs of 3. The beginning,
Yeah.
right here, so there's a run of 3.
And then there's another one like 1, 2, 3, and then 5th to the 6th.
Here's a 3.
Oh, yeah.
That's how I see
Is that it?
The fourth to the fifth, like around that.
Can it be in a 4?
it.
No. 4, no? Yeah.
Is that it or not?
Oh, you're
Yeah,
good.
can it be part of the 4?
No.
Run the 4?
No,
Can be.
no. Is that the,
Are there only 2?
Yeah.
Okay. So there's 2 of those.
and then there's corrected.
Then the runs of 2, I'm just going to do all in red, I think, because let's just see, or maybe not, I don't know. Run of 2, so here's a run of 2. Here's a run of 2. Here's a run of 2.
Right next to it.
The 2 H's, right?
Yeah.
Yep.
Okay, so then the 2 H's, 2 T's, 2 T's again.
10.
Holy moly, there's a lot of these. 2 T's, 2 H's, 2 T's, 2 H's. Is that it?
Yep.
Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 10.
Yep.
So 10 of these. Okay, so when we're looking at those, let's see, alright, whatever. Alright, so now let's look at table D. I guess we can look at actually let's use our calculator. Let's use a calculator. Instead of looking at a table all the time. Alright, so in your calculator, if you pull that out, I'll pause while we're doing that. Okay, so in your calculator you can go random int. Where will I find that? Math. I'm guessing probability. And down below, math, PRB. You might want to write that down if you didn't know that. You can go to random int. Alright, and so when you do random int, you want one number at a time. There are 2 possibilities. And then there are going to be 50 trials. And what this does is, it'll give you a list of numbers, and you have to designate which one's which. So let's say that the 1s are heads, and the 2s are tails, because that's alphabetical. Is that all right with everybody?
Yeah.
Then I hit enter, and it generates that list.
Is everyone's going to be different?
Yes, unless we space it
Well,
out.
what happens is everybody should be different because your calculator, if you've ever used random numbers, then you will have a different scenario. However, if we all cleared our memory right now and started from scratch, everybody's would be the same.
What if we did it again? Do the same again?
If you reset your calculator, they'd all be the same again.
No, I meant like if you pressed it one more time.
Is I want you to write down what we did to get this stuff. So we did random int, and then it was 1 because we want there to be 1 at a time. There were 2 possibilities, 50 trials, and then I'm going to write down what I got on mine so I don't have to scroll through all of my calculator, but you can scroll through and do the same thing or write them down.